the evolutionary theory. What's the observation?
There are like countless different kinds of observations you could make for evolution.
One. The best one that you think supports that it's a theory, the best observation you got.
The fossil record and genetics.
Okay, I observed a fossil or a collection of fossil, right? So the observation is fossils, plural, okay? Is the question what causes fossils, plural?
What?
I'm asking you, if you found fossils, what's the observation?
Really quick, we don't... So the fossil record was used to build support for evolution, but then there are fossils that were predicted to be out there that we then found. So the fossils are not just observations, and then we form a theory around the observations.
Excuse me.
The fossils are the evidence that was predicted as well.
Stop for a second.
Mm-hmm.
You just said we use fossils to support the theory.
Mm-hmm.
You didn't even get to the theory because you need an observation to get to the theory first. So you're starting with the theory, and then you're finding fossils. You have to do it the proper scientific way, which is start with an observation. You don't assume the theory because you didn't get there yet. You have to start with the observation, not tie an observation to your assumed theory. This is not science. This is pseudoscience. So again, if you're going to claim that you found fossils, is there something specific about the fossils you're calling your observation?
Yeah, the characteristics of the fossils. So, for example, Archaeopteryx was predicted to have existed before its fossil was ever found. It should have intermediate traits between theropod dinosaurs and birds, and it does.
Okay, hold on. Again, you're telling a story about the observation. In science, you start with an observation, just purely, and describe it, okay? So what are you purely observing with fossils, please? Very clearly.
The anatomical structure is the most obvious thing you can observe with fossils. And then by observing the anatomical structure of modern living birds and extinct theropod dinosaurs, the prediction that an intermediate fossil form should exist was made, and then it was discovered.
Hold on. We're not talking about predictions. We're starting with the scientific method. This should be very easy for you. Now focus.
It is.
The observation is a fossil exists, and it shows the phenotype, the anatomy of a certain bird-like creature, and you're comparing that to an observation you have presently with an anatomical, similar bird-like creature, correct? That's the observation.
No, I said theropod dinosaurs and modern birds. So what was... Go ahead.
I'm just saying, in clear language, you're discovering a fossil and you're looking at its anatomy and you're comparing it to modern anatomy, right? In short, that's your observation.
Yes, because what evolution tells us is that the organisms of today are the descendants of organisms of the past.
Stop going to the theory. I'm asking. Stop it.
I'm telling you the scientific steps.
You can't interpret the observation with the theory because the theory is at the tail end of the theory. You have to pretend you don't know what the theory is.
I'm talking... Archaeopteryx was discovered only a few years after On the Origin of Species was published.
I don't care about the story.
Evolution was very much hypothetical at the time, and I'm telling you what happened when it was very hypothetical.
You can't even get to the...
Before genetics, before the modern synthesis, before any of that
stuff.
Stop your
story. Stop the filibustering storytelling. I don't care about your stories. Observation. There is a fossil that has an anatomy. There is a current animal today that has similar anatomy, right? All I'm asking you is that the observation?
That's one of the observations, yeah.
Okay, let's start with that.
Yeah.
Thank you. That was really hard. Observation. Old thing has traits, typical traits, anatomy. Current thing has similar things, right? The next question in the scientific method is, what causes the similarity, right? That's your question?
I never asked a question. What are you talking about?
I know, because you didn't do the scientific method. Thank you. So the next question in the scientific method, Peterson, is you start with the observation, and now you're asking a question about the observation in nature, the similarities between these two things. So isn't the question what causes the similarities between these things?
Yeah, and then that would be genetics, which was discovered farther down the road.
Hold on a second.
What is going on?
If the question is what causes this phenomenon you call similarity in traits or anatomy, right? Your hypothesis is now this. what causes similarity, correct?
A hypothesis is not a question.
The hypothesis is positing X causes Y, correct?
Yeah.
Okay. So what is X in this scientific method? We got to the observation. We asked the question, what causes the similarities, right? You have fossils, and that's your observation, right? A fossil and the current bird that you're referring to. Hypothesis is X causes Y. So what is X?
You could say common descent. You could also say genetics.
Question big.
No, it's
Isn't
not.
common descent to the theory itself?
It's an implication of the theory, yes, but we would look at.
So you can't.
We would look at
okay,
any.
Stop.
Go ahead.
Common descent is a post-diction, basically story of what is occurring. We're asking for something that's X that you could introduce to produce similarities between these two things, right? The phenomenon is similarities in phenotype, right? So now we're asking a question, what causes similarities in phenotype? And you've skipped to common descent, which you can't introduce into an experiment. You can't introduce common descent and remove it. This is not science.
What? We do evolutionary. What? We do evolutionary experiments all the time.
I didn't ask if you think we do evolutionary experiments.
I don't think we do. We do.
I'm trying to. I don't care what you think we do right now.
I don't think that we do. We do. Like I can cite you some.
I don't care if we do right now. We're supposed to be doing one right now, dude. And the observation is similarity in phenotype between an old thing and a new thing. Question: what causes the similarity?
Common descent.
Hypothesis: common descent. So is common descent something you can introduce into an experiment?
Digging up fossils really isn't an experiment, but that doesn't make it not scientific.
That doesn't answer my question. This is cross-examination.
I'm pointing out the red herring of...
No, a red herring? You said X causes Y, okay? Is it correct that you're saying X equals common descent, Y is similarity between these two things?
I'd have to write that down to keep track of it, but what I'm telling you is that the reason the Archaeopteryx transitional form exists is because theropod dinosaurs are the common ancestor of Archaeopteryx and modern.
That's begging the question, dude.
It's not begging the question.
Listen, I'm going to ask you more.
Is
you need
evolution
to answer my
true?
questions now.
This is the kind of evidence we would predict. It was found.
I'm not asking for
supporting evidence of X.
Stop it. Peterson, stop. This is my cross-examination.
I know.
Observation. We'll do this real slow. Observation. There's an old thing that shares anatomy with a current thing. I ask a question. What causes the similarity? Your hypothesis is
that common descent causes
it.
And then we found the evidence that confirms
Hold on.
Keep interrupting to minimum, please.
Stop it. Okay. You posit that a thing called common descent is the independent variable that causes similar anatomy, correct?
There's no independent variable.
I'm asking a question.
And your question is flawed, which is why I'm informing you that doing paleontology doesn't have independent variables because it's not an experiment.
Therefore, it's not science.
That's complete bullshit.
You can see it. Dude, does a scientific
There are all kinds of things.
I'm asking the questions.
I'm answering your question.
No, you're not. Listen, you just said it. You conceded the debate right now. Why?
No, I didn't. You fucking moron. It doesn't. You don't have... No!
Can you develop a scientific theory without an experiment?
Absolutely.
You can. Okay, so what's the need? Why use experiments then if you could just develop theories without experiments?
Because they help.
They help? Okay, so I can just develop any theory without an experiment and you just believe it because I don't have an experiment to be the arbiter of two competing hypotheses.
There's more.
Over.
You literally started... We're actually doing this earlier. There's other kinds of evidence, like just mere observations, than experimental evidence. But that doesn't mean that it can't be part of science.
Observations is the first step, dude. I didn't say it's not part of science. I said observation is the first step. Now tell me, how do you arbitrate between two competing viable hypotheses without an experiment?
You can look for evidence like let's say I think that George Washington was actually a woman, and somebody else says, I think he was a man. We go and dig up his bones, and we find...
It's not even a scientific theory, dude. scientific theory. We're talking scientific theory.
We're talking about how do you delineate information absent an experiment. It can be done. I just demonstrated to you that it can be done.
I did not ask if you can gather information. I asked you, can you develop a rigorous scientific theory without the scientific method? Again, I'll read my opener here. Scientific theory is a likely explanation of what causes an observable natural phenomenon based on an experiment using the scientific method. The scientific method goes as such. Observation. Ask a question. What causes Y? Posit that X causes Y. Introduce X, remove X. Repeat. Conclusion. Develop a scientific theory. Now, I've demonstrated that for your, quote, theory of evolution, when I ask you what's the observation, you say there's this anatomy we found. It looks like this other anatomy we have. Look at the similarities. I ask you, interesting, what causes the similarities? You say common descent. I ask you, can you introduce common descent and remove it? You say no. I say it's not a scientific theory. You say experiments are not necessary for scientific theory. Let's take it down a notch here. Let's say scurvy. Can
I address that or not?
No. So
Okay.
so scurvy is a symptom, right? A set of symptoms. Scurvy.
I would call it a condition. The symptoms.
Condition.
Yeah. Sure.
Okay, great. It's a condition. Is it fair in the scientific method, inside of natural science, to ask the question, what causes scurvy?
Yeah, that's fine.
Okay. Could I arbitrate between two hypotheses of what causes scurvy without an experiment?
It wouldn't necessarily have to be a controlled experiment. You could literally just read ship logs and see, wait a minute, those people on that ship, they took not freeze-dried, but like preserved vegetable, like fermented cabbage, fermented foods. Like that was a way to because they didn't have refrigerators. So they could get their dose of vitamin C. Nobody knows what vitamin C is back then. But anyways, you could literally just look at the historical record and you could say, hey, wait a minute, these people were, they had that kind of food. And then this other group of people, all they ate were meat preservatives and crackers and things that. They got scurvy and then they didn't. That would be supporting evidence. Now, ideally, you would go on to do experiments that help validate.
Hold on. I understand, Peterson, hold on.
Yep.
What you just said is that's an observation and that's the moment you're actually forming a hypothesis, right? Right. Looks like one ship had oranges and vitamin C and a way to preserve their nutrients, and that ship didn't get scurvy, but this other ship is missing something. That's a question, and I would argue, and I think you would agree, that that's actually where you introduce your hypothesis.
Sure.
Okay, so I'm asking you, again, if you have two competing hypotheses, right? Let's say someone else says that's not the case. Is there any way other than an experiment to actually arbitrate between the two competing hypotheses?
Yes, because hundreds and hundreds and actually thousands of ships have sailed, and you could look at the records of all of them. You're not producing the data yourself. You're not doing the experiment.
That's an observation.
But if you say yes, but these are observations that confirm what your hypothesis is. If this is literally how studying the past works. Now we can study evolution in the present, but this is a little bit of a tangent, but other scientific theories like the Big Bang, we don't recreate the Big Bang. We do recreate certain conditions to know some things about the first moments of the Big Bang, but literally all of it is just observations. We did the math.
It's just data.
We said there should be these predictable things out there in nature that we see, and we found them.
Hold on. Can false assumptions accurately predict phenomenon?
Seems reasonable that could happen.
Okay, if two different models or hypotheses are saying, look, I'm observing the data and you're observing the data, I think this is causing the phenomenon that's predictable. They both have a predictable element to them. One is true and one's false, or maybe neither are true, right? I'm asking you, if someone's looking at data of thousands of ships, I don't care if it's 1 million ships, and it looks correlative that the ships that have food preservation technology and vitamin C don't get scurvy, and the ones that don't, they do get scurvy. That's an observation, that's data. I'm asking a different question. When we introduce a hypothesis of what causes the phenomenon, is there any other way to arbitrate between two competing hypotheses than an experiment? Your answer was, yeah, more data. No, you just said more data. So no, the answer is no, because I just told you two people could have the same wealth of data and posit different hypotheses about the cause of the phenomenon, and one could be wrong or both can be wrong. The question is, how do you determine in natural science who's got the correct hypotheses other than an experiment?
I literally answered this question for you.
With more data.
What is it that experiments give us? More data.
I'm not saying
the data that is produced by an experiment. I'm answering your question. The data that is produced from the experiment can absolutely exist in other cases that have already occurred. So there's no meaningful difference. Experiments are great because you can control
Hold on a second. I want you all to listen to what he just said. The data post-experiment is no different than the data pre-experiment.
That's not at all what I said. I said the data that is yielded by an experiment is in no meaningful way different than the exact same kind of data from the exact same type of scenario you would set up with the experiment, but it's already occurred.
Okay, so here's the thing. The question isn't whether or not you call the results and information you gain from an experiment data. That's not what we're talking about, right? We're talking about whether or not pure data without an experiment can give you a likelihood cause. And I'm saying no, and you're saying yes.
That's because you're wrong. I can explain it to you.
Wow.
I can explain it to you.
Can you develop a theory? Can you develop a look? Let's do it again. There's a ship that comes in, and they're sick. There's a ship that comes in that's not sick. We look at the contents of the ship. We see the one ship that's not sick has all of this stuff, right? Vitamin C, preservation. The other one doesn't. We make a correlation. We go, this is pure data right here. We can actually work with this data, right? I'm asking a different question. Can you develop a scientific theory of what causes the condition, illness, without doing an experiment?
Yes.
So why does science need experiment then?
Okay, let me try to bridge the divide that we have here. I think how this originally started was you were trying to get me to tell you how could you get data to support it without the experiment. Now, two ships come in, we make an observation about this ship has a bunch of scurvy, this doesn't. We look at what kind of foods the one ship had, we look at the kind of foods the other ship had. We build a hypothesis that says it's due to these vegetables and fruits or whatever. We don't have to run an experiment to get data that confirms that, because we could literally just watch every single ship that comes in after that point, and we have nothing to do with the way it's set up. Those kinds of things are sometimes called natural experiments. So you can do all of that without setting up, like in a lab or whatever, the conditions for it. Now, what I would say is,
hold on. No, don't filibuster.
Well, no, I was actually going to try to agree with you.
This is okay. Okay, go ahead. I'll let you just good faith. Go ahead.
I will absolutely agree that ideally you would want experiments, like controlled experiments or whatever, because they eliminate a lot of external variables that allow you to laser focus on what you think is happening.
Okay, I'll ask a question. Let's say we didn't know what caused scurvy, and there was a grant out with two scientists, right? If one scientist was you and one scientist was me, right, and there was a reward for who can develop the scientific theory of what causes scurvy, would you go ahead and present just a correlative argument of the data between ships, what they have and what they don't have, and one clearly correlates to the sickness and one doesn't? Or I do an experiment introducing oranges, introducing and removing oranges and food preservation technology, and I repeat that over and over again. Who's going to get the second grant, me or you?
I don't know.
I am. Why? Because I developed a scientific theory using an experiment, and you didn't develop a scientific theory, and you just merely made a correlative assumption. The difference between a correlative assumption, or let's call it a hypothesis, and another hypothesis is the only arbiter for who's correct in their hypothesis is an experiment.
Jimbob, the problem there is you and I are going to have the same data. It's just that you obtained your data in a different way. I'm going to have data that says if they eat fruits and vegetables, they don't get scurvy, and so will you.
Oh, you didn't. You look, the same data that's happening. For instance, let's say, I mean, I couldn't think of a more simple example than this, but I'm going to have to try to think of an even simpler causal example. Let's say poison. Okay, let's say someone's poisoned, and we don't know what caused it. What's the poison, right? You say, well, there's a bunch of poison in this room that's kind of toxic, so it's probably that caused it. And I go, well, there's a variation of poisons here that may have caused it. And you go, yeah, there might be a variation of poisons that caused the death of this person consuming it. You're saying to develop a scientific theory, you don't actually need to introduce the poisons and test which one causes the kind of condition or death. You can just assume, because there's poisons around, that your scientific theory is pure data. There's poisons, and maybe he ingested poisons, right? That's all you're saying, right? We have access to the same data. The problem with your pseudoscience is that the only way to develop a scientific theory, right? Let's look, I'll make it simpler. I choose one poison and you choose another. They're both in the room, right? Peterson goes with this one and I go with this one. I say, oh shit, Peterson, we have competing hypotheses. How are we going to develop a scientific theory of which of the poisons killed this person, right? Can you imagine the coroners taking Planet Peterson's approach to science? Can you imagine what that would look like? They don't need to do a scientific experiment to investigate what causes.
In the 1800s. Like literally what you're talking about, John Snow in London in the 1800s did this. He was noticing cholera outbreaks, and what he did was he mapped all the city's wells, and then he mapped where like human waste was being dumped, and then he was able to conclude, he thought that it was caused by the human waste, and then he mapped out the locations of all the wells in London, and then the locations of where the human waste was being dumped, and he found, look, the cholera outbreaks are happening in these specific spots,
that's
and
correlative
they're not
data.
happening in these other spots.
That's correlative data. That's
now,
great and useful. We agree.
What you could do from that point to advance the theory is say, okay, well, why? What causes cholera? Well, I think that it's not just poop, it's bacteria in the poop.
That's
so you can advance the theory that way. Yeah.
Well,
but you're
that's
pretending that you can't get the same
dude.
Kind of data.
Stop.
Yeah, I stopped.
You just posited the hypothesis. You said advance the theory. No, you don't. You're basically saying you can get a scientific theory without doing comparing and arbitrating between the two hypotheses. Okay, again, Eric, we're at a party. It's a murder mystery. There's a death. Peterson says, dude, that shrimp has poison in it. And I go, dude, this other thing, there's a poison bottle right here with a jabber on it, like a little pricker, right? And you go, well, I think the shrimp caused the death. And I go, I think this poison caused the death, right? So the question is, right? The question is, how are we going to arbitrate between your hypothesis, the shrimp caused it, and my hypothesis if we have the same data? There's data. There's shrimp. There's this. There's a dead person. How are we going to arbitrate between the two competing hypotheses?
You could, in real time, have different groups of people eat the shrimp and then collect data that you could collect. Is
that a scientific experiment?
You could collect data in the present.
Is that hold on?
Or you could get the exact same kind of data by looking at events like this that have already occurred.
Dude, what you just said is feed the rest of the group different things. I agree. The two maniacal scientists. Hold on. How else? No. You just said the proper way. Introduce the variable X shrimp and variable X1 poison. Inject people with it, and then that's an experiment.
Yeah.
And then you could tell what happened, right? I'm saying, how would you know other than doing that? How would you know what caused the death?
Again, you could look at, it's kind of weird to call it a historical record in this case, but we could look at like,
4.5 minutes left, and let's try to keep it all on topic.
This literally does happen. I mean, we're seeing it with outbreaks of avian influenza now, or like with the E. coli outbreak with McDonald's. I mean, we already know that E. coli causes food poisoning, but it's like, well, was it from the lettuce, or actually it was from the onions for McDonald's? Well, let's track down the onions. Let's track down the farm. Let's track down the distribution. Let's look at the cases of people getting sick around the world. We're not performing an experiment, but we're confirming our idea there nonetheless.
Look.
Experiments are great. It's not the only way.
I didn't ask about what you think confirms, because there's two different hypotheses that correlate with the data accurately and accurately predict. If the fact of the matter is two competing hypotheses could both correlatively predict things, we're asking a different question in natural science. You said that E. coli, we know E. coli causes this. Well, that's interesting, because that's a claim of natural science, that E. coli causes this type of sickness, right? We wouldn't know that unless we isolated E. coli and introduced it into bodies to see what it caused to do. Now, if there's a whole shit ton of food, and it turns out that people are eating all sorts of food, and lettuce is one of those foods, we have to determine which food correlates to the sickness. Now, with higher resolution, we look at the lettuce and we go, oh shit, it's nothing about the lettuce. There's actually something on the lettuce. It comes from feces. It's causing this. Let's say we didn't know what E. coli was, but we only knew that lettuce seemed to be the correlative agent here. Well, the only way you can develop a scientific theory in regards to the data you have is to investigate what it is that's actually entering the body, introduce it to the body, remove it from the body with two sample sets, do a scientific experiment, and then see what happens. Is it null? Does it verify your hunch that this little microscopic piece of shit went into someone's stomach and caused all this brutality internally? Yes, you can actually introduce it. That's the problem. To tie it back to evolution, observation is fossils in the past look like fossils in the future, or not even fossils. Looks like something in the past. They have similar traits, right? Yeah. I ask, what causes this? Peterson says, common descent causes this. I say, interesting. How do you introduce common descent and remove it such you know that it's causal to this phenomenon? He says, you can't do that. That's a concession that you can't introduce and remove common descent.
Well, you can't you can't remove it because you can't change the past. If
you can't take it to the scientific method, then
yes, you can.
New hypothesis, please.
We do evolutionary experiments today.
I didn't ask what you think we do. I'm asking you specifically about this observation.
What kind of statement is that?
Dude, listen to me. Observation, again, there's a thing in the past that looks like a thing in the present. They look similar. The question is, what causes them to look similar? You say a common descent.
Yep.
That's like a category, right? A common descent. This occurs, okay? So how do you introduce common descent and produce the phenomenon, remove common descent, and see if the phenomenon's still there?
1 minute left.
So really all you're saying is we can't make the course of history.
I asked you a question. This is cross-examination. Don't tell me what I'm saying. I asked you a direct question. How do you introduce common descent and then remove it to know that it's causing the Y phenomenon?
The idea that because we can't rerun the course of history means that that evolution can't be like a scientific theory.
I didn't ask for a meta. I didn't ask for a meta. I did not ask what you think is stupid. I asked you if you're saying in natural science that common descent causes the Y phenomenon. I ask you a scientific question. How do you introduce the independent variable common descent into a situation and remove it so you know that it's causing the phenomenon of similarities? Just say you can't answer it and go to a new hypothesis, dude. Bite the bullet.
No, well, we could confirm it in different ways. Down? We could test the genetics of archosaurs and birds today, and then we could. Yeah, I'm addressing this thing here. So we could confirm it in the present by testing the genetics of archosaurs living today and birds living today, because that is the data that would be predicted by common descent, and then we find it. So anyways, we're out of time, but...